Morning to all. Today we are discuss about factors contributing good line design. In order to reduce the hazard that lightning poses to power system, certain factors that determine the line performance must be understood. The objective of good line design is to reduce the number of outages caused by lightning. First, we try to keep the incidence of strokes to the system to a minimum. Then, we try to minimize the effect of those strokes that do terminate on the system. Lightning problems can be eliminated if all transmission was through tunnels at least 20 feet under the ground. Tall towers are more complex than low goal post-like structure. In order to prevent the lightning, some adequate clearance must be provided. High ground impedance or tower footing resistance are to be avoided. High surge impedance in ground wires, tower structures are to be avoided. Next, mathematical model of lightning stroke. During the charge formation process, the cloud may be considered to be a non-conductor. Hence, various potential may be assumed at different parts of the clouds. If the charging process is continued, it is portable that the gradient at certain parts of the charged region exceeds breakdown strength of the air or moist air in the cloud. Hence, local breakdown takes place within the cloud. This local discharge may finally lead to situation wherein a large reservoir of charges involving a considerable mass of clouds hangs over the ground, with the air between the cloud and the ground as a dielectric. When the streamer is discharged occurs to the ground by first leader stroke, followed by the main strokes with considerable current flowing. The mathematical model of lightning stroke may be throughout the current source of values I0, with the source impedance Z0 discharging to the earth. If the stroke strikes an objective of impedance Z, the voltage built across it may be taken as V is equal to I into Z. That means I0 into Z into Z0 divided by Z plus Z0. That is equal to I0 into Z divided by 1 plus Z divided by Z0. The source of impedance lightning channels are not known exactly, but it's estimated to be about 1000 to 3000 ohm. The objects of interest of electrical engineer, namely transmission line, etc., have surge impedance less than 500 ohm, overhead lines 300 to 500 ohm, ground wires 100 to 150 ohm, tower 10 to 50 ohm, etc. Therefore, the value of Z divided by Z0 will usually less than 0.1 and hence can be neglected. Hence, the voltage of lines, etc., may be taken the approximately V is equal to I0 into Z, where I0 is the mathematical modeling of lightning stroke current and the Z in the line surge impedance. If a mathematical model lightning strokes current as a low as 10,000 amps strikes a line of 400 ohm surge impedance, it may causes an overvoltage 4000 kV. This is heavy overvoltage and causes immediate flashover of the line conductor through its insulator string. In a case, direct stroke occurs over the top of the unshielded transmission line. The transmission line waves rise divided into two branches travel on the either side of the line. Hence, the effective surge impedance of the line as seen by the wave is Z0 divided by 2, and taking the above example, the overvoltage caused may be 10,000 is equal to 2000 kV. If the line were to be 132 kV line with a 11 10-inch disc insulator string. The flashover of the insulator string will take place as a impulse flashover voltage of the string about 950 kV for a 2 microsecond front impulse wave. The including of lightning strokes on transmission line and substations is related to the degree of thunderstorm activity. It is based on the level of thunderstorm days TD known as isolic level, defined as the number of days in a year when the thunder is heard recorded in a particular location. But this indication does not often distinguish between the ground stroke and the cloud to cloud strokes. If a measured ground flashover density is obtained, then the number of ground flashovers can be computed from the TD level. From the past record, the past experience, it's found that Ng is equal to 0.1 to 0.2 TD slash strokes slash kilometer per year. It is represented TD between 5 and 15 in Britain, Europe and Pacific West North America, and is in the range of 30 to 50 general eastern states of USA. As much higher level is reported from the South Africa, and South Africa no literature is available for the different region in India, but a value of 30 to 50 may be taken the coastal areas and for the central parts of the India. Model. In lightning studies, the strokes to ground are of importance as they induce lower voltage on transmission line in nearby objects. Hence, model-based lightning return stroke is presented here, which assume that the lightning channel is straight, vertical and normal to the ground plane. The return stroke current is assumed function vertical of coordinate z and time t, and the initial I0 and t importance engineering application. The electromagnetic field is associated lightning current, and the lightning induced voltages are calculated based on the return stroke current equation as. Then return stroke current will be I z comma I is equal to z divided by b. Then z lesser than Vt. Then next one I z comma t is equal to 0. Then z greater than Vt. Where v is the return stroke velocity. Assume the current pulse propagates without attenuation and distortion in the upward channel. Since the current varies both in the space and the time, the electromagnetic field and electric field is associated with the calculated with using Maxwell's equation for time varying field. Whenever a transmission line near the stroke channel, there will be a coupling between the line and the stroke channel. The total voltage induced on the line is computed solving the coupling equations involving the total induced voltage U comma x of t and the induced current I x comma t. Assume the transmission line in the direction. An equivalent circuit coupling is given by Agarwal, from which voltage at any length x is equal to L can be computed. The next one, the model calculation of the equation, the equivalent circuit for coupling between the line and the stroke. Input side supply voltage, then transmission line, and due to capacitance effect it will be reduce the reactance level and then load. It will be connected to the equivalent circuit in the form of mathematical model, where L is equal to length of time, then R0 R1 terminal resistance, L dash comma C is equal to inductance capacitance of line per unit length dynamic, U dash x comma t voltage developed at any distance x, I dash x comma t, current through the line at any point distance x. E dash comma x comma h comma t, electric field in direction x at a height, transmission line height, Zg is equal to equivalent ground impedance. The factors that influence the lightning induced voltage on transmission lines are the ground activity, the leader stroke current, and corona. This induced voltage based on the Harvard model are modeling the taking into account these parameters with the computer analysis, the prediction of over-voltages on the transmission line and the lightning performance of the line, that is flash over rate on the line insulation can be predicted accurately. Thank you.